Hey, what's up? My name is Andrew. I'm going to kill you. My name is... You hear that? Yeah, great. Yeah, great. My name is Andrew. I usually go by Andrew Mohawk. I work at a crypto company. I do security. I'm basically like the trained person of security. I'm not going to say the word. I do security in my free time. As you can see at the bottom here, I'm smart as a bag of rocks. And everything from this point on in the presentation is hallucination. Okay, so I'll cover that this is very cutting-edge research from literally 9 days ago when I was like, hi, I think that I might have something. We're right on the edge now. And this is the second device that I purchased. Well, the second device is the one that I purchased. But unfortunately, I bricked that last night. So it's been a ride. This is the one from my house. So we're hoping that that doesn't break during this presentation, as it did right at the beginning. So we're just going to wing it from here. Also, everyone was like, AI will make your slides. Don't worry about it. Let me tell you, I have 55 versions of trash slides. They're just over there. I like it for some things, but slides is not one of them. And there you can see over here, this device was delivered on July 8th. So it lived for 1 day before I killed it. So before this, I built a bunch of harnesses. I did a lot of like CVE research with AI, and we'll come back to this right at the end. But this time, I didn't use any of that. I was just like really lazy, basically. So I live in this imaginary place called Flytown. It's very different to Stytown and unrelated. But it is one of the largest imaginary rental places in the United States. It is, in fact, the largest one. There's like 110 buildings. There's 11,000 apartments. And we have these like great little intercoms. You know, you buzz people up. It's cool. But the intercom doesn't come with anything. Like you have to be at the wall. You have to press a button. And you get 2 cameras for this, 2 floors for each individual one. And all I really wanted to do is I just wanted to open the door. I was just like, cool, I just want an app. I just want to be like, cool, Amazon is here. I press it. I need to get out of the bed. Life is hard. But also there was a lot of bureaucracy. Like if you wanted to get extra cards, there was a lot of hassle. Like how do you revoke them then? And the device was just like in my apartment. So it's kind of mine, almost. So like why can't I just have an application? So I was like, all right, well, I'll take it apart. So I removed it carefully from the wall. As you can tell, it still works, mostly, we hope. And I was like, okay, it probably has like either a thin 2Y protocol, or it's going to do some like proprietary RF nonsense, or it'll have like a web API that I can use. I can just figure it out, grab a token, I now have a web app. It's great. But it doesn't. It has PoE Ethernet at the back of the device, and that's wired into every apartment. And I was like, oh, that's strange. So I went into the admin menu, and as you can tell, I did real hacking over here, okay? Because this side, this side, it tells me the passwords. None of those passwords work. The password is, in fact, 4 zeros. None of those 1s or 9s, so I'm a real security guy. Okay. No, that is the default, just they didn't have it in the Google AI response. So you can't trust AI on anything these days. Okay, so behind the monitor is basically a PoE device. If you go into the device, you can see like the network ranges, you can see the /18. It's an indoor monitor, so it like sends and receives the calls and whatever else. You can open the doors. Also, I've not really completely looked through all these slides, so this is kind of the first for all of us. It's going to be great. Okay, so I was like, cool, I want this, but unfortunately the World Cup was on. I don't know if you've seen the World Cup, so I was like, oh, this is what I want to do instead of this. But luckily, I had AI. So I was like, Codex, okay, here you go. I'll connect you to the computer that's connected to the wall, hypothetically, and then I will be like, you make an app, and it's going to be great. And I'll come back to this. And then I watch the game. You can see here I am with my cat. Even she loves games. So we're both all having a great time. And then after, I don't know, 90 minutes, I came back, and it was like, hey, no problem. I got all these cameras for you. I was like, okay, well, my building can only has 2 cameras, so that's a bit weird. Like those are my cameras, And ironically, none of these are my camera. So, but I found quite a lot of them. So then I was like, well, now I'm obviously nerd sniped, so I'm going to have to buy things. So I was like, okay, I bought a PoE router. I was like, this should be fine. And then just LAN tap. I was like, cool, I'm going to get this. I don't need sleep anymore. I can just look at this thing. I can take apart my lounge. It'll be fine. Everything is connected into the lounge. it's hacking time. No, I just tell robots what to do. Okay. So I didn't even run the nmap. Really depressing. So I was like, okay, I'll nmap. So on the device, I see the range. I was like, cool. Let's nmap everything because now I know there's other things out there that I can see because I can see these cameras. So I find there's like 4,000 odd devices, and they have like Mac OUIs. So I was like, okay, well, that's the name of the thing. So these must be right hypothetically. But it's only 4,000, and we're on a /18, but I was like, that seems low, but maybe like I can only see my building, or only the buildings around me or something. Ports are open, there's like, I don't know, a handful of UDPs, one TCP port, and offer some sort of weird proprietary thing. This is when I was going to try. I was at the keyboard typing manual commands. I was like, oh, netcat. I was like, I don't know, this is garbage. It took me a long time, and then I was like, okay, it's time for the robots again. So then I was like, hey, robot, I need you to figure it out. And smarter than me, it was like, bro, someone else already figured this out. There's a Home Assistant plugin for this. You can just grab it and you get the code. I was like, nah, I should have thought of that. That would have been great. So basically, you just send this UDP packet, info, it'll tell you what the device is, tells you all about it. And I was like, okay, I don't know why we're laughing. That seems like a very reasonable protocol. So anyway, you send this to it, it tells you like, oh, what its logical address is, what its sub-address is, what hardware it is, what firmware it is, all the kind of things that you'd be interested in, but over UDP. So I was like, okay, well, this is pretty good. Well, almost. Very close to encrypted, though. Very close to it. Adjacent to encrypted. So it comes back to like all the devices, and there's like a whole bunch of different kind of devices in the hypothetical place, and like they're basically run into like these categories. There's basically like a wall monitor that lets you like one of these, one that works and one doesn't. There's an entrance panel that lets you pick like, oh, I can see all the people who live here. Oh, sorry, the virtual directory. I can see all the people who live here. Then entrance panel that sits above that. There's like the camera, and it manages the call from the device to that camera, so you can see the person coming to do delivery. There's IOMDs, so basically they control things like IO ports, so like doors, things that it connects to, like it sets off the balloons, whatever they've got connected in this place. And then management infrastructure, so the things that you can configure it with. So I was like, okay, well, what are all these things? Anyway, there's this thing called Viper. It's a great name. The Viper logical address is basically an address that you get that routes to your individual device, and then these devices just DHCP for as much as they want, and they first like initialize and say, hey, I'm this person, almost encrypted as well, and then it assigns like an IP address to that, basically like a routing table, and it'll know how to route to you. This stuff, basically you don't need it. Look, I mean, the libraries I have are going to do it anyway, but there's a couple of headers in the bytes. You basically like open a channel, you say something. The best part is you say authenticate, which I was like, okay, it's fine. Now we have this authenticate, everything is going to be fine. We're back to security. These are the things I know. So when you start a connection in any way, you send this open UAUT. Why we couldn't just have the word auth? Unsure. Would have fit in those because you can only have, in here you can only have four bytes. It's user auth, which turns out users are every device. So anyway, so you send a user auth, then you send open a channel. It basically like validates this. If you look at it, there are two kinds of basically like things that you start with. You either start with authentication or configuration. Authentication, you just say like, hey, I want to prove who I am, and then we can do our stuff. Or configuration, I want to either upload a config or download a config. You can see where this is going to go soon. There's a couple of other things that happen. So once you've set up that, you basically like have to auth for most things. Then you can do, then there's like, everything runs in this one TCP layer, and there's a bunch of like different essentially protocols that are in there. So CSPB and CTPP basically like to set up the call to say like, hey, I'm calling this person, or this person is calling me. It just says like basically the metadata around the call. And then the other one starts at the state, so it says like, these are the channels that we're using. This is how we're going to communicate. So we'll get to that a bit later. And then RTPC for your video channel. And then there's something called TSOK, TSOC, not sure what they, obviously I haven't spoken to the hypothetical companies either. So UATs, this access request, you say like, hey, you have to send this bearer token. I was like, wow, okay, we're right on Web3 here. This is us. We're going to take off. But then you can SNMP walk everything, and you'll be surprised. But with the public community string public, you can get everyone's tokens. So really, there's not a lot of authentication that happens. I mean, it does authenticate, but you can also grab the tokens. So if I wanted to get the device info, from here on out, who knows what happens at demos? I don't know that it's gonna help unbrick these devices. That was something. Okay. I have no idea. I didn't get it. Sorry. Something new. This is Malibu. So if you're wondering, I am drinking neat Malibu. Okay. So here is the first request. So basically, it does this. Yeah, but then you can't see the cool thing on the shell. Okay. Yeah, I mean, I guess we can. Okay. Here you go. So basically, we do the SNMP. We get the token, then we request the token, and we get all the results from the device. I mean, this demo does nothing, so it's a good one. It worked. Terrific. It's the next ones that I'm worried about. Okay. So now we need to mmap more stuff, because originally we did this, right? So now it's like 4,000, but then I remember reading on Wikipedia about the imaginary place I live at, and they had 10,000, places. So I was like, well, where's the rest of them? So like, where are these other 10,000 things? So I went to do real hacking again, and I used traceroute, and I could figure out how the routing works for the network. So I was like, okay, this is where they, transit through. I know that I'm sending UDP to get info, so I start trying to figure out where everything is. There's a bunch of 18s, /18s. So I get 50K responses. I start looking through them, start doing SNMP walks, things like that. Everything is SNMP. So depending on the device, so you could first get the info of the device, you can figure out what kind of device it was, and it also tells you the firmware version. Everything is kind of old, so if a lot of them you have to do a V1, some of them you can do V2s, which is obviously easier, but you can still get all the results. You can see that most of these results came from V1. Okay, so a quick side channel, we'll get back to this just now, but that VIP is your routing layer, so that says that's my identity, it routes to me, and that will actually have children of that for each individual panel you have. But everyone only has one, including me. Okay, so if we looked at that, this is basically what the network looks like. If you work at any of these places, look away. Yeah. So this is the network. It's pretty big. There's a lot of stuff. ChatGPT obviously made this. So here are these are individual apartments, and there's a video entrance panel, directory, I don't know, other stuff. All kinds of things in here. But the other thing is that when I do the SNMP walks, I can enumerate those directories. And when I enumerate the directories, their whole purpose is to just be okay, here's Andrew, and here is the VIP number that he has. And also, here's his apartment number, because when you press down, you need to see apartment number and the person's name or whatever. So you can also kind of enumerate all of that. And as a side thing, this hypothetical place, it doesn't exist only exactly here. It could be anywhere. But if you SNMP walk the devices as well, they obviously tell you the floor, so you know how high up someone is. And then also you can get the geopositions of apartments. Anyway, I'm just saying, so you can see here, you can go through, let's say if there was a resident by my name, oh look, there's me, it's the only person that's real on here. And then also, so these are all the apartments, then I could say show apartments, and these are all the apartments that have responsible directories. And then I've tried to put them near where the apartment physically is, and then color-coded them by height, so that you could essentially be oh, I can see the people at either the top or bottom, to figure out where they are. And it should cluster them based on how many people stay in one apartment. Anyway, just trust me, it does it. I mean, that could have all been a lie, so I don't. Okay. Yeah. How do I get back? Latest. This is the one that counts. No, this is great. Okay, so I can't be on the Wi-Fi and have the device work because the routing table was destroying itself. But we can try now. You know what? One of us has a microphone. Okay, so now I'm starting to look at like the monitors themselves because I was like, well, it's interesting that you can like map the network and see all these things about it, but like how do the things on the network work? Now I've been like fully nerd sniped. I was like, okay, I got to figure this out. So basically what happens is that your individual device that sits in your apartment will speak to the intercom system that you have in your building and say like, hey, I'm Andrew, here's my VIP number, right? And it does it with that cool authentication method that we covered earlier. And then what happens is when you press it, so the entrance panel over here will speak to the intercom system and say, hey, where do I route this? And then be able to make that connection. And those connections are actually TCP connections when we actually make the calls. And they do like the setting up a state, how we're going to like do the different video and audio codecs. So some of the devices are not full duplex, so you can only have one channel at a time. So they will have two channels and then just swap the whole time, which is an interesting way to do it. But I guess they're like older devices. So you can see it like over here. So we start a call setup, then we do call control that says like, okay, this is who I'm calling, this is where we're going to communicate, how we're going to communicate, and then at the end, like this is where the media is that we're going to speak about it. But a lot of this is not very stateful. So these are like protocols that are like inside this TCP layer, and once I can easily like fake another side's connection without it like ever knowing. So basically like when we're talking about media layers, we start with like the outer layer that's, it's got to be 44 bytes. Then we discuss like where it's going to happen, who's calling, who we're calling to, and where the reference is. But this goes over UDP, so, and it's multicast. So everyone can see every call in everywhere. So, so if you, what is this place? No. What do I call it? I know. Don't worry about it. I remember. Okay, so this will stream calls. If someone knows someone in a hypothetical place that's nearby, if they could just press the buzzer, then I would be able to see it. I don't know how well this demo was going to work. I was just hoping someone would have to do it in this time. Okay, well, we tried. There's other demos on it. Okay, so if a physical call happens, this is how it sets up. We do UDP, we set up like the state, we tell everyone what's happening, then we send a command that says, hey, you should ring, which is hilarious because it wouldn't know to ring if it just got the packets. Why not? It already sees the call coming in. That's crazy. Then we talk about ports and we negotiate like what type of media, because a lot of these devices are like older devices, so they can't support like newer codec protocols. So we like downgrade that, and then we release, then we'll get out of it. But when this is happening, like obviously that channel is taken. Like you can't receive 2 calls, you can't receive any more than 1 call at a time. But anyone can also fake it because there isn't like a really good stateful way. So if I wanted to do a demo, and this demo is going to be the one that we find out if this still works. This device should still be on. That's a great start. Okay. Oh, okay. Really? Okay. Oh, this is not the one I want actually. Nearly got a different demo.
Don't break it.
Well, don't break another one. Okay, we're going off the Wi-Fi real quick so that this reads properly too. Okay, so it's now sending to the panel and it should be ringing. Okay. Now I've turned off disable the ringer, so now you should be able to hear it ring. Okay, these demos are song. Hey! And now you can pick it up. And of course, like you control the RTSP stream, so you can just put anything that you want inside the stream at any time. And you can see everyone else's talks, everyone else's calls, so like you can intercept those as well. Tell me you've got over we'll cover it later. Okay, so then I was like, okay, well, actually I need to find out more about the device. It's pretty tricky from the outside. It only has this one port. Like I'm working with a proprietary protocol that I can't get anything for. So I disassembled stuff. I'm just kidding. I codex disassembled stuff very well. But I told her to download all the firmwares. Like we pulled those. I was like, hey, you know, how can we access this? And this for me was one of the best parts. So it was like, okay, well, I looked into it. There's a UDP function that you can use to get a backup of the device. It's called backup. It's great. So it does a backup. It does TFTP. TFTP to download it. It grabs the backup. Inside the backup, please tell me it's in the slide. Oh, yes. HTTP enable 0 password and the app manager password. So luckily, you could set those, or you could just query anyone's, because obviously you can do that without any authentication. So then you can grab that. Then you can change it from 0 to 1. It's quite hacking. And then you can upload it, because the backup function also takes a response. And they can open it, and then you have a backup. And the best part of this was that then it was like, hey, I found that the backup has command injection. So I've changed the file name to be something else, and now we have a root shell. So that's what it did, all on its own while I was watching football. I was very impressed with it. Like you see there at the bottom. I was like, okay, that's pretty good. So obviously like a very basic, a very old attack, but like still very effective here that I had a root shell. And obviously once I had a root shell, I can like look at all the processes, see how the device works. I can map the whole thing. So here I can see that there are a couple of functions that run on all of these listeners, and they all kind of work the same. There's like a whole range of them by the same company and by a couple of others. But basically there's like an extender that sits on the network side. Then there's an MQT broker that runs in the middle, and things that run on the device. And the thing on the edge puts stuff into the broker. The things that are on the device basically like pick up from the broker, and they can like use the hardware for whatever they want. And that's how that works, and including like writing to the frame buffer, speaker, microphones, touch buttons, things like that. Like everything basically happens locally through this app called Kinder. And that's just like a stock Qt app that's been built. So then if we're looking at it, these are 5 basic things that run inside of this broker queue. So keyserd, it does like backup and restore, which we already covered, not great. Commit is the auth levels, covered that already as well. There's local broker outbound status, something that's like a watchdog, and then like a device functionality. To write into the queue, you can get the password from the config that you can query without the password. So you can get that pretty easily to be able to write into there, but they've figured this out, so it's limited to localhost. So you can't actually write into it easily. But luckily, they built something to solve this problem. So what they have is, well, don't know where we're going with this. Oh, yes, this is a better one. Okay, so there is something called TSOK that we covered a little bit earlier. And basically, that exists on the edge as part of the protocol. And like we can find if we like disassemble it, it's mentioned everywhere. And basically, you can query from the TCP layer to this, hit that. It will put something onto the broker, and then now you have, you can do whatever. You can put anything on there. It will just put anything that you send it, which is quite nice. So if we're looking at like, why do they have this? They have this basically for like output calls and doing things on the devices. So the output call comes in, it hits that edge. This writes to that queue. The queue like then does this. If we look at calls, so I was like, okay, I can make a call and I can change stuff. So then I was like, well, how does the speaker work? Like, how does it just know what to send? Because a lot of these are not full duplex. So they have something that's doing like send and receive, but separate channels. So there's basically like a whole protocol where they just like increment numbers to figure this out. And of course, then if you have this TSOK, then you can write to the queue to be like, hey, we're just doing that part of it. That nearly went badly. So we have another demo here. I really wish I put numbers down. 4? No. What was the one you just did? Damn it. What was 3. Oh, okay. We're not there yet, apparently. 5. No, yes. Okay, so we can just tell it, like, hey, we're in a call, and we're recording the microphone. Because you need to be, well, I mean, we're not actually saying record the microphone. We're saying this is the stream that you want to send the data to us. And the device has no idea on the state because, like, it's just not very good at state. So I'm hoping this can work. Is this thing on? Yeah, it turns off to save power or something. Okay, so here it is. It's connecting to, no, okay. It's ringing now, but yeah, it automatically picks up because, of course, you send the ring command, but also you can send all the other commands. So now it's, you can update the ringtone. Yes, you can update everything on the device. It's in the config. Oh, you could just not make it ring. You could just not send the ring command. I mean, this is just for, like, an example. Okay, so here it is. So here it is, just recorded, like, from the device back onto us. So you can, like, take all the devices and be like, hey, I use it as a microphone, which is cool. Everywhere. You can have more than one in an apartment. So, like, in the bigger apartments, they're like doors, bedrooms, and, like, living rooms.
Yeah, I already have Alexa.
Yeah, but now everyone has your Alexa. Okay, and then, of course, I can, like, also be like, hey, I want to just, like, send data to it. That's right. That is the Rude Sandstorm that will be playing through this without anything that happens. Okay, so we can just stream stuff into against everyone's will as well, which is hilarious to me. So you can. You need to speak to the hardware manufacturers if you need to make that louder. That is as loud as I could get it. It is quite loud in an apartment, I'm sure. So I was trying to solve this, and also I'm on a visa. I know this seems like a terrible talk for that, but I had to, like, meet the lawyers to discuss, like, the next O1 steps or whatever, and then this thing just started playing the Rude Sandstorm at, like, full volume during the thing, and they were like, what is that? I was like, I can't end the call. I don't know how to stop it. I don't know what to tell you. So that was great. Okay, so we had this one method of getting root where, like, we basically take this SNMP token, we get the config, we change the stuff, we re-upload the config, we wait for the device to reboot, then we take that upload, we do the command injection, and then we can get a shell on the device. But obviously, like, maybe they fix SNMP and we can't get it. So luckily, we found some other ways to do it. So what you can do is you just need that UAT token, which you can get from the public strings and from every other device that's in there. And then, this is not the right slide. Wait, we're going to find it. Oh, where is it? Here we go. Every single one of these has a very simple command injection. So as long as you can write into the queue, you can also access the like a bunch of the different devices that they have for debugging without any tokens. So one of them, I hope that it's in here. It should. Obviously, these were made by AI as well. Oh yes, remote.command debug exec. That's a fun one. It runs in the context of the thing, but has, like, straight command injection. Like, it is just adding whatever you send to it to command line and executing it. So you can now, like, just root all the devices remotely as long as you can connect to the TCP port, which you can from anywhere in the network. And if you looked at the network graph, there's, like, printers and, like, all kinds of things on there. It's not just, like, only related to the infrastructure that makes it. No idea what this. Oh, here it is. See, we were so close to that slide that I was looking for. Okay, so all of these are the different places that you can just use command injection. So you just connect to it. You say config. When you get the config, you can pull the token. When you have the token, you can query TSOK. When you have TSOK, it hits MQTT, and that will, depending on the command you send, do one of these, and that will just, like, own the things. So this is my other device. This is a Planix. It costs $250 on eBay. It's very sad for me. But it actually doesn't run it doesn't run a Linux machine. It's like a custom OS that they have. So I was like, wow, this is going to be a lot harder. But luckily, they put the passwords everywhere. So it wasn't too hard to find it. So one of the things is like it will accept new firmware, but only if it's been zipped with the right password, the way that everyone does good security on firmwares. And you can find the password basically everywhere. Like I could crack it, and I could also find it in different places. And it's also just a single tweet that I have, hypothetically. Then some of the other devices that I found, this is another one of the Planex devices. So I would love to demo these things. These took the most time until I bricked it. They will take a brand new firmware that you can upload. They do TLS verification. They have all these things, but then they also accept, so by default, they will check that your packages are signed, but they will also accept a SHA-1 that you can send with your package, that they will validate matches your package, and if it does, is verified. So it wasn't as good, yeah. And then this was just one of the ways that you could like get into the device, so you could just like change the pointers. Okay, this one is number 3. So this one I hope works too. So if we have root on the device, and this is going to get root. Okay, the device is on. It's going to, so now it's going to use that method to get root. We hope. I'm not stressed at all about these. It should be fine. Okay, it's second stage. This is looking great. So now it will go into the device. It'll get root, and then because we have that kind of application that like listens to the queue and like does everything and integrates with the hardware, I can just remove it. Like I will just kill the process, and then I can always like add my own process, and I can do that like over the network. So I'm optimistic that that has uploaded an image. Oh, now it's switching the screen to. It should be a picture of my cat, hopefully. It's great. It's my cat Mia Chopstick Legs, and now that device is unusable. You can only have a picture of my cat as your intercom forever, which is also very funny. But I did put in something to get out of this.
Do it to the building. One way to fix it. Make them fix it.
What is that, the Konami code?
The device is mostly back. Okay. So also like going through the code, like we did a lot of reversing. The manufacturers are actually, what I think is really cool is they release a lot of their firmware so you can like take it apart and look at it. I mean, obviously they don't release it for that reason, but it's nice that you can find it. There's tons of plain text values. There's a lot of like SNMP walk everything. You can get all these like app tokens. There's a lot of like SSH private keys, all kinds of things that you really don't want to find in there. And I guess like it's an older system, so sort of the things that we've been talking about for a long time in security. But obviously, like if you put it together, like okay, so you can get root through a TCP port from anywhere on the network, and that network includes, like let's be honest, the leasing office because they have like 7,000 printers, all called something leasing. You can kill the application that, right? You can kill the application that like stops, the intercom from being useful. You could permanently kill it if you wanted to. You could just like move it somewhere. You can write to the screen. You can play audio. You can record stuff. You can read the hardware buttons. And then, of course, you can always restore it. Like at any stage, you could just put it back, and there would be no way like you can run it in temp. So this is my demo. Well, let's see if this one works. What is it? 6? No, 7? No, it must be 6. Hey. Okay, so now we're going to do that. So we're going to root the device again. This one is a little bit tricky. And then it's going to upload like a much bigger payload because the device actually is pretty decent. It has like 256 megs of storage. And it is now putting it into the MQTT task to get the root shell. So there you can see like we've got a root shell, ID is root. Now we're going to upload it. We're going to send it to the frame buffer so we can like take over the device. At some stage it should go like 3 bars. I can't see the device, so it's a bit weird for me here. Well, now we hope. Okay, it started the stage. Okay, it stopped it. So now it should hand over to ours to take over the frame buffer. So now you'll see that I've made a special Summercon version of Doom. I've customized it for this device. It has like a good frame around it. And you can play it. I put some little icons there. So, what? So if you want, you can come play Summercon Doom. It's terrible. It's very difficult to play Doom on one of these devices. I would say it wasn't a great choice of game. And the other game was that it was a game where you jump along as the intercom trying to. It's a game where you jump along as the intercom trying to collect all the SNMP passwords that you left. I get it. Okay, so like, what's the worst that can happen? Like, worst case scenario is pretty bad. Like, you can reroute calls, you could change someone's like identities, you could be like, hey, whenever someone tries to call someone else, it comes to me. You can keep all the doors in state so that they can't open or close. So like, generally open is fine. Like, if people are inside the building, they can always get out because they can physically press the door. But obviously if they're outside, they can't come in. You can lock up the devices, you could just make it play noise, like all kinds of bad stuff. You could be like, hey, there's a biohazard in the building. I'm going to scream this at 3 a.m. in the morning. It could cause a lot of chaos. And like, really, there should have been a lot of places that should have been stopped. And like, things that we've said for a long time, like, you know, you need to separate planes. There needs to be like different trust layers. A lot of the standard things that we have. But I think like this was the most important part, is that like, I just use stock codecs. So this was just like a $20 subscription, and me being like, hey, I want an app that I can open the door, and then asked it a couple of other things. But like, none of the things that I asked it were like very like, I gave it like a lot of prescription on like where it should go, and it managed to like do everything. And I think like the risk is that like, we've been saying these things for a long time, like, hey, you need to have like secure defaults and things. But like, what if someone like is like, hey, I want to change the signboard at the airport to be like, lol, Andrew was here. Like, that's going to be a real bad day for everyone. So I think that we might be finding out real soon. Also, I wanted an app that opened the door, and I still haven't built it.
Questions?
Oh, does anyone have questions?
Hi, thanks for the talk. How'd you break it?
That device only has 4 megs of memory, and Doom is like 4.2. So I was like, don't worry, I got this. What I will do is I will zip Doom, then I will provide a small lib that unzips, and then I will unzip it into memory. Except I got the address wrong, so I now have a device that only has Doom on it, but no operating system. So it's unfortunate for us.
How many months did you work on this?
Well, I think it's in the first slide. It's 9 days ago. Wow, there was a lot of slides in this presentation. Yeah, see, nine days ago I started and was like, hey, this looks great. I think I might have a talk. So, yeah. There's a lot more stuff obviously involved here. Like, I suspect that like the protocols themselves, you can like change things in between. Besides, like, if you switch from like a calling protocol to like intercom and back, like what will the devices do? It looked like there were a bunch of like memory issues, but I didn't have time to go into them. And I guess I didn't really need to. Like, there's already root shells, so it's, yeah. Cool. Thanks.